All right, hello everybody. Well, only two of you, but welcome. I know this is not the start of the semester that we had hoped for, but in these uncertain times, we have to be cautious. And so thank you guys for for coming here virtually. I know this course was planned to be in person, but just want to be safe during these times. So, all right, so let me go ahead and share my screen. Right.
Hello, Professor.
Hey, how's it going?
Pretty good. How are you feeling?
I feel okay. It's my throat is pretty scratchy, but my fever has kind of died down.
Ooh.
And so I'm just kind of waiting just the results of my test. So
Okay.
but yeah, thank you for accommodating this. I know it's kind of a big change on the first day of class like this.
Yeah,
But
no, better safe than sorry. So
yeah, for sure, for sure.
I appreciate that.
Mhm. Hey, Samson. Yeah, a little bit. My fever's died down, but my throat's still a little bit scratchy, and I'm coughing a bit. But yeah, still just waiting for my test results, and then we'll go from there. But yeah, feeling well enough to teach. But yeah, just don't want to expose you guys. That's the only thing. Yeah, I know, right? Yeah, I wonder what it's like there today. Thanks, Abraham. Hey, Ryan. Good afternoon. Thanks. Yeah, I feel okay. I think it's more just just trying to be as conservative and just cautious as possible. Yeah, my fever's down, but I'm still coughing just a little bit. But yeah, feeling well enough to teach. So excited for today. How's everyone else doing today?
Pretty good. Can't complain.
Doing pretty good.
Good, good. This summer felt simultaneously very, very long, but also very, very short at the same time. It's I feel like all the breaks always like that, but yeah.
Professor, do you know when you're going to get your results for your test?
So I got tested on Sunday, and so they said it will be 1 to 3 days, and so I'm hoping either sometime today or tomorrow, and then we can go from there. And so if I test negative, then Wednesday we'll be back in person. But if I test positive, I have another test scheduled for this weekend too, and then so I'll wait till I test negative before we return to the classroom.
Okay.
I'm going to marry Harvey Dent. I love him, and I want.
Someone's watching Dark Knight.
That was me, Professor. My bad.
Oh, no problem, no problem. All right, it's 4 o'clock, so let's go and get started. All right, good afternoon, everyone. Welcome to the new semester. I apologize, I know this class was scheduled to be in person, and and I myself was looking forward to being in person, but as you guys saw, in the email, I am experiencing some just fairly mild symptoms. I had fevers over the weekend. I've been coughing, so I just wanted to be safe, because I don't want to come to the first day of class and then infect you all with COVID. That would be a terrible way to start the semester. So, so first of all, I want to say thank you guys for being accommodating. I know, it was kind of a last minute thing, but I appreciate you guys being here, virtually, and and hopefully we can get back to the classroom as soon as possible. Okay. And the nice thing about Zoom is that this lecture will be recorded, and so I think if there's any lecture that I think that should be recorded, it's I think this is an important one, because we're going to be introducing this course, which is a brand new course, and we're going to be talking a lot about the syllabus and a lot of the policies that we have today. And so I think if there's one thing that I'm going to miss about Zoom lectures, it's this record feature, because I think it's really nice to be able to go back and see these things. So at least for now, we'll have the recording. And we'll be virtual, but hopefully we'll be back real soon. Okay. All right. And so usually this is when I make a joke about this is EGME 441, engineering biomechanics, and so if you're not in the right room, you can feel free to leave now, but it's Zoom, and so hopefully someone didn't click the link by accident, which can help, which can happen sometimes, but hopefully not too much. All right, so let me start off. So how's everyone doing today? I know I just asked 5 minutes ago, but some people just trickled in. So how was you guys this summer? How are you guys feeling about the semester? How are you just feeling in general?
Feeling good about the semester, but I'm kind of nervous for in-person exams again.
Yeah.
I haven't taken an in-person exam in like a year and a half, so.
I know, right? It's it's gonna be a transition again. It's gonna be I hear you. I think with all the COVID stuff, I think there's understandably a lot of anxiety too, but also just I think test anxiety that that I think you feel in person that you don't feel at home too. So
Oh yeah, much different. You're way more comfortable in your own office or bedroom or something than you are in a classroom. So
for sure,
the sense of anxiety is totally different. Yeah.
For sure. Yeah. So I actually, yeah, thank you for reminding me about that too. I didn't think about that. So once the exams come around and and then they'll probably be in person, then I'll definitely keep that in mind. And we'll do everything we can to kind of relieve that, because I know it'll be kind of a transition back for everyone for that. Mm-hmm. Good. Looks like everyone had a good summer. Yep. Yeah, I was at the graduation. I didn't see too many of you, but I was wearing a mask and I had a hat on, so I think it was kind of hard to recognize me. So some people who like kind of walked right up to me kind of recognized me, but then yeah, I didn't see too many of you. But I saw all of you though. I saw you guys get called and I saw you walk across the stage. So it was definitely like a proud parent moment, because a lot of you guys have known for a long time throughout your Cal State Fullerton experience. So it was I was really happy to see you guys walk across the stage and graduate. Okay. All right. So all right, so let's go ahead and get started with the lecture slides, right? Okay, so today's the first day. So for the first day, I usually like to take things easy, just because I know we're all coming back from summer break. We're all trying to get back in the swing of things, and so there'll be no equations today, no calculations, no no hard stuff. Let's usually I spend the first day just talking about just the course in general. Okay, and especially for a class like this, this is like I told you before, it's a brand new class. I've never taught this class before. This department has never seen this class before, because I kind of just made it up last year. And so I really want to spend the time to talk about what my goals for the class are, what you can expect from the class, and just what the heck this class is all about, right? And so it's kind of like I always like to think of the first day of class as like reading kind of like a good hook for like a story, like a movie that you're watching, right? And so the hook or the or the beginning of the story should kind of give you a sense of what you can expect from the book or the movie or whatever. Okay. And so that's what I want to do today. Okay. And today's gonna be really casual. So if you have any questions, definitely don't feel shy. You can put the questions in the chat. I'm in presentation mode right now, and so hopefully Zoom has fixed the thing where I can actually view the chat during presentation mode. But if not, you can turn on your mic and ask any questions as well. Okay. All right. And so this is the first lecture for EGME 441, and the title for the class is Engineering Biomechanics. Okay. And this is fall 2021, and my name is Professor Justin Tran. Okay, learning objectives, right? And so I know a lot of you guys, you've had me before, so you kind of know what these are all about. But if this is your first time with me, I always like to start every lecture with learning objectives. Okay, and so just like I mentioned that whenever you come to a new experience, you should kind of know what to expect. I treat every lecture like that too. So when you come to the lectures, the first thing you'll see, or one of the first things you'll see, hopefully on the board once we get back in person, is I have a list of learning objectives. Okay, and those are, you can kind of think of those as that's kind of my goals for the day to try to get you to learn. Okay, and so I always recommend to people when you come into the classroom, when you come into the lecture, write down the learning objectives, because that's kind of like your checklist for the day, to say that here's all the things that I should learn today, or should be able to do. And then by the end of the lecture, if you look back at the learning objectives and say, I did that, then that's probably a good day. All right. And so today, it's really simple. We're just going to define what biomechanics even means. Okay. We're going to describe some engineering applications of biomechanics. And then we're going to talk about the syllabus. And so we're going to talk about course policies and expectations. Okay, so a little bit about myself. So my name is Professor Justin Tran. I'm very relaxed about what you can call me, and so call me whatever you feel comfortable with. And so a lot of people call me Professor, a lot of people call me Doctor. Call me Justin. Whatever you feel comfortable. I always put this out as an offer every single semester, but no one has taken it up on me yet. And so if you want to call me something like Dick Face or something like that, I'm okay with that too, right? So I grew up in the era of online gaming, so I've been called all manner of different things. So it doesn't bother me. So as long as it's comfortable for you guys, then it's going to be comfortable for me. And so that's usually my policy about what you can call me. Okay. All right. So my office is in the CS building, and so it's a little bit different from the other engineering faculty, because there's no more room there. And so I'm on the 5th floor CS, CS 526. And so if you're having trouble locating that, I'm right in front of the computer science department's department office. And so my office is kind of just right there. Okay. I'm currently in my 6th semester, and so I think previously I would always say that I'm still fairly new here, but now that I'm in my 6th semester, I think it's a little bit I can't keep saying that now. Okay. Right. My email is very easy to remember, and so it's justran@fullerton.edu, right? And so you can think of it as you just ran a marathon or just ran a 5K, right? So I'm from here, so I grew up in Cyprus, which, if you don't know, it's about maybe about 8 miles west of Fullerton, just right down the 91. Okay. A little bit about my education background. So I got my bachelor's from UCLA. I got my master's from UCSD, my PhD from Stanford, all of which in mechanical engineering. Okay. And in terms of my research interests, I'm really interested in using engineering tools for studying heart and blood disease. Okay. And also in better ways to doing STEM education. Okay. And so this class, where we're going to be learning about, biomedical applications of engineering, this is kind of right up my alley. And this is kind of, exactly kind of why I wanted to teach this class, because I feel like there's not that many classes like this. And I think it's a super interesting area that, a lot of you guys have told me that you're interested in too, right? And so I know a lot of you want to work for, companies like Medtronic or Edwards Life Science. And so, this class is kind of geared towards, giving you some of the knowledge that will help you, contribute in those companies that, our department normally doesn't have. All right. Okay. And so what is engineering biomechanics, right? So first, right off the bat, okay. And so biomechanics, I think, is kind of it's kind of a misleading term, because it makes it seem like it's something really different and exotic, but it's not, right? So biomechanics is just mechanics. And you guys all know mechanics, and so you've all learned it up to this point, okay? And so you've taken classes like statics, you've taken dynamics, you've taken strength of materials, right? These are all knowledge that can be applied to biological systems too, Okay, it's just that, you know, the person who came up with biomechanics just decided to give it a new fancy name, but really there's really nothing fancy about it. It's just, you know, everything that you've already kind of learned as a mechanical engineer, you're just applying it to biological systems, primarily the human body. Okay, and so when I say mechanics, what I mean is, you know, the study of forces and motion. Okay. And so biomechanics, therefore, is the study of forces and motions on living systems. Okay. And for this class, you know, what we're going to focus on mostly is the human body. Okay. But of course, you know, you can apply biomechanics to a bunch of other stuff as well. Okay. And so what the challenge of biomechanics is not really in the equations, or not really in the foundational knowledge, because, you know, you guys all have that already. Like, you understand forces, you understand Newton's laws, you understand how materials work, right? And so you all know that. But the challenge in biomechanics, what you'll see, is actually in the practical complexities. And so things like irregular geometries, things like inhomogeneous or nonlinear material properties. Sometimes you're dealing with several states of matter. Okay, because I think, you know, normally when you're thinking about things like statics or things like strength of materials, you're thinking of very regular geometries, right? You're thinking of a beam that's literally just a rectangle just extruded out, right? It's a relatively simple geometry. And so you can apply the equations of motion directly to it. Okay. But that's not true of the human body. Okay. And so for the human body, you have a lot of very curved and kind of strange geometries, right? You have a lot of very strange materials, right? And so if you took apart your muscle right now, you know, you can't really say that, you know, we have a single Young's modulus for this muscle, or you have a single density for this muscle, right? It's very irregular. It's very nonlinear. And so, you know, a lot of what we're going to learn in this class is, you know, how do we apply what we already know about mechanics to these kind of complex geometries and complex material properties. Okay, but, you know, but just because it has a name like biomechanics, it shouldn't scare you. And so, you know, it's a lot of this class is going to be me convincing you that, you know, you already have a lot of the information you need. It's just you know, applying it in kind of an interesting way. Okay. Okay. So any questions so far? All right, and so what are the areas of biomechanics? And so, you know, this is a little bit subjective, and so this is kind of how I think about biomechanics. But, you know, other people have probably a different way to kind of break these down. But I like to think of biomechanics, you know, in kind of three different categories. Okay, and so the first category that I like to think of is called performance. Okay, and so performance, when I talk about performance, what I talk about is how living things do stuff. Okay. It's a very vague term, but, you know, I think it's a little more clear from the example. So things like walking, sitting, standing, throwing, reaching, swimming, right? And so just moving your body, right? And so if you kind of, you know, stand up, do a jumping jack or something like that, you know, that's performance. Okay. And it can also refer to some kind of internal movements that you might not have full control over. Okay? So things like blood flow, things like muscle mechanics, things like joint kinematics, things like that. Okay. And so, you know, when I say that, you know, we're going to study performance in biomechanics, we're going to be really quantifying, you know, how fast someone walks, or how much force someone can exert when they you know, contract their muscles, you know, how far they can throw something. Okay. All right. And so the next area of biomechanics is injury. Okay. And so injury refers to the failure or damage to biosystems. Okay. And so things like broken bones, things like torn muscles, torn ligaments, organ impairment, all things like that. Okay. And so any kind of, you know, effect or failure inside your body is going to affect, you know, how your body performs. Okay. And so for this class, you know, when we think about injury, you know, we're mostly concerned with how to evaluate tissue properties. Okay. And so, you know, how is the muscle tissue going to be affected when it's torn, right? How is your bone going to heal after it's torn? Okay. And specifically for engineering, you know, once we understand how the injury happens and you know, how it can heal, you know, we can design devices to either protect the body from injury or to help it heal. Okay. And actually, that's the third area of biomechanics, which is rehabilitation. Okay. And so rehabilitation is the recovery from injury or disease. Okay. And this is actually where a lot of engineering comes into play, right? And so, you know, a lot of biomedical engineering, you know, we design devices to help people, recover from injuries. Okay. And so things like a wheelchair, right? And so that was designed by an engineer to help someone recover from an injury. Okay. And what's trendy really a lot right now are things like implants, things like, you know, prosthetic limbs, you know, a lot of, you know, things that we can, you know, 3D print, right? And so a lot of these devices that, you know, that can assist in someone recovering from an injury, you know, engineers play a big role in that, okay? And in order to really, you know, design these devices effectively, you know, you have to really understand how the body works and how the tissue is going to heal, okay? Okay, and so let's go over some applications, okay? And so because I think, you know, this is always important because, you know, whenever you have, you know, a class like this in engineering, it's always nice to see what the end goal is, right? And so, you know, so let's talk about some engineering applications of biomechanics. And so the first one that I think, you know, that a lot of people we interact with every day is in our shoe design, okay? And so what I'm showing you right here is the design of a sports shoe, okay? And so there's a lot of engineering that goes into a sports shoe, right? Because you want to, as you know, especially for, you know, people who either have to, you know, walk a lot for their jobs or they're athletes and so they have to run a lot, right? You want to make sure that their running motion is as efficient as possible and puts the least amount of stress on your body, okay? And your shoe design has a lot to do with that, okay? And so, you know, there's ways that you can design your shoe such that, you know, it distributes the force, you know, as you come down, you know, you step down, it distributes that really well. And it makes it so that your muscles work as efficiently as possible, okay? And so, you know, there's a lot of engineering that goes into these shoes, okay? And that's, you know, and especially later on in the semester when we talk about gait analysis, which is, you know, the analysis of, you know, watching someone walk and, you know, and quantifying the forces and the motion of someone walking, you know, a lot of that science goes into, you know, designing like a sports shoe like this, okay? You know, I mentioned wheelchairs before, right? And so wheelchairs are, you know, it's a device that, you know, a lot of us are familiar with, right? And so there's a lot of engineering that goes into these devices just to make sure that they you know, that they work well, that they support the patient as much as possible, that they're easy to use, they're easy to push around, that, you know, they don't introduce unnecessary risks and things like that, okay? Actually, you know, I know a couple years ago, there was a senior design project that worked on, you know, I think a special device for a wheelchair as well, okay? I think what they worked on was a device that stops the wheelchair from tipping over, you know, in the event that, you know, it falls over like that, right? And so there's a lot that an engineer can contribute to something like this. Right? All right, and so let's talk about just rehabilitation in general. And so what I'm showing you here is, you know, someone who, you know, something terrible happened to their legs, and you see a lot of engineering devices here, right? And so just on the outside here, you see that he's using some crutches to support himself, right? And so, you know, that has to be engineered as well, just to make sure that they're strong enough, that they're light enough, okay? It might seem like a very simple device, but, you know, you'd be surprised at how much engineering and product testing goes into something like that, okay? And then the thing in the middle, right? And so you have these braces that are holding up this this person's legs, you know, to make sure that, you know, either the bones or the muscles or, you know, however this person hurt himself, you know, those things aren't taking any stress, and all of the weight and all of the load is being taken instead by this almost like an exoskeleton that this guy is wearing, okay? And so, you know, as you can imagine, you know, a lot of engineering goes into these things because I'll tell you right now that the doctors that work at the doctor's office are not designing these devices. They're just using them, right? And so behind the scenes, there's a lot of engineering that goes on. Okay. Nice. Yeah. So Samson just commented that he injured his MCL this year and he 3D printed a small knee brace to help keep your knee straight. That's perfect example of you know, how you know, of what we're going to learn in this class, right? And so you know, I think that's awesome. So I think you have kind of a leg up on this class already. So pun intended, right? All right, so let's get into more advanced stuff. And so you know, another really interesting area of biomechanics is surgical robotics. Okay, and so, you know, what I'm showing you right here is the device called the Da Vinci, which is kind of the flagship device for this company called Intuitive Medical. I think that's what they're called. And so what they do is they design this device to kind of you know, to kind of perform the operation on a patient, instead of the surgeon having to hold the tools and you know, and do the operation. Okay, and so the way it works is that, you know, the surgeon is standing here at the console, kind of like in this kind of like Wizard of Oz kind of you know, VR kind of set right here, and he's using these kind of controllers here to kind of control all the different apparatus to perform the surgery on the patient. Okay. And so these are really cool devices, and you know, you know, a lot more hospitals are picking up on them because they eliminate a lot of the risk, right? Because if you have a machine that's kind of controlling, you know, these probes, which, you know, normally you have to hold really steady, you know, that eliminates the need for a human to kind of do that. So, you know, it eliminates a lot of the risk. It makes these surgeries a lot more clean, right? But in order to design these devices, you know, you need to, you know, first of all, understand robotics and you know, how, you know, to move kind of a lot of, you know, robotic appendages like this. But you also have to understand a lot of biomechanics, because a lot of these devices are going to be designed to either cut through tissue or move through human tissue, right? And you want to make sure that you're moving through these things as precisely as possible, right? And so that requires like a really intimate, a really detailed understanding of how muscle tissue works, how, you know, blood vessel tissue works, right? Because you don't want to create something that's, you know, going to give too much force that it punctures the lungs or something like that, right? And so, you know, I think this is a really cool area where, you know, obviously there's a lot of robotics going on, but also a lot of biomechanics that's needed to design something like this too, right? And even something really simple, right? And so I wanted to do an example of a device that helps with injury prevention, okay? And I think one that everyone's really familiar with is bike helmets, right? And so your bike helmet, you know, everyone tells you to put it on before you go biking or skateboarding or scootering, right? And it's designed to protect your head from injuries, okay? And so even something like this, you know, it might seem like it's simple. It's just, you know, a piece of plastic or a piece of styrofoam that you're putting on your head, you know, but there's a lot of really interesting engineering that goes into this too, right? Because, you know, when you're designing a device like this, you're talking about preventing injury from a blunt trauma, right? And so the worst case scenario, you know, someone falls off their bike and slams their head against the concrete, right? And that's really hard to design for because it's a very sudden, it's a very high impact kind of injury, right? And so you want to make sure that you design these helmets so that they distribute the force, you know, throughout the helmet, and none of that actually goes into the person, okay? And so, you know, they may seem like really simple devices, but you'd be surprised at the amount of engineering and biomechanics that goes into these things. Yeah. Okay, and so I want to ask you guys. So, you know, we've talked about some applications of biomechanics that, you know, that I thought of, you know, literally for 5 minutes, you know, when I was making these lecture slides last week. But, you know, I know a lot of you guys, you know, I know a lot of you guys, you come into your classes, you know, with the goal of, you know, what you want to learn about. And so, you know, I want to turn this to you guys and say, you know, what are some applications of biomechanics that you guys are thinking of, that you guys you want to learn more about? You know, and I like to ask this for my electives because, you know, with these kinds of classes, you know, we can kind of take this class into, you know, almost whatever direction that we want. And so, you know, I like to ask what you guys are interested in so that I can steer the class, I kind of steer the topics towards, you know, the things that you guys are really interested in. Right. All right. All right. So let's take a look. Massage guns. Yes, actually, yeah, massage guns are a great example. So I have to admit that I was not a fan of massage guns before, but my fiance bought one recently, and I love it. And so it's a great device that it does a great job of kind of loosening up your muscles. So I definitely love that. Yeah. All right, so devices for hearts such as stents, medical devices. Yeah, excellent application. We're not going to talk about that too much in this class. I actually have another class that talks about stents a bit more, so that's 442. But also, you know, very interesting device as well, for sure. Resistance training, yeah, that's a great application. And so, you know, we'll be talking a lot about muscles, and we'll talk a lot about, you know, how they grow and how they, you know, and how you can design devices or even training regimens to help build them. So resistance training, I think, will be, you know, super interesting too. Right? Hypervolt, nice. Right? Prosthetics, yes, absolutely. Really interesting application area. You know, obviously has a lot of synergies with this class. We'll definitely be talking a lot about prosthetics, you know, later in the class as well. Yeah. Brain neurodulation or biomechanics at the cell levels. I'm not sure what the brain thing is, but we'll but yeah, but cell level biomechanics also extremely really interesting as well. You know, we're not going to talk about too much on the cell level because I want to keep this class to kind of macro level stuff. But you know, it's also really interesting too, right? That's kind of the unfortunate thing with kind of the format for this elective class is that it's, you know, I don't really have a chance to kind of build on anything like this. So this class is kind of, you know, it's kind of designed just to be kind of self-contained and kind of like a one-shot. But biomechanics, you know, it actually encompasses a lot of really interesting stuff too. So like Samson mentioned, you know, there's a lot of blood. blood flow stuff and heart stuff that, is really interesting that, we unfortunately can't get to in this class. And there's a whole level of like microbiology, cell level microbiomechanics that's, that we can't get to in this class, but is really, really interesting as well. Laser probes for eye surgery. Oh, wow. Yeah, that sounds really interesting too. Yeah, we won't get into really any eye stuff because I want to focus on just kind of the mechanics of like muscles and bones, but that's another really interesting too. Yeah, that's another area where it's like, I wish we had more time, or, I wish I had a follow-up class to go into that, but unfortunately we don't have time for that. But yeah, but another super, super interesting area as well. Device of Parkinson's disease. Yes, that's a really, really important, really interesting area as well. Yeah. So anyone, any kind of disease where, if you struggle with kind of, neuromuscular control, design devices for those people, to help, just to help them get through their day or to improve their quality of life, I think is really, really, important. Yeah. Actually, I think I saw recently, I don't remember if it was Parkinson's, but someone designed like a vest or like a jacket that makes it really easy for someone to unbutton it, because I think it's normally really hard for someone to, because if you think about it, buttoning up or unbuttoning like a jacket, it requires really fine motions of your fingers, and some people have a condition where it's really hard for them to control that, but someone designed like a jacket which makes it super easy to kind of unhook those things, and I thought it was super cool. Yeah. Stroke recovery, yes, another great one too. Yeah, so people recovering from a stroke, they sometimes they have a lot of trouble, either controlling parts of their body, or sometimes they lose, they just kind of lose motion in certain areas too. So design devices to help them, get through their day and improve their quality of life is another, really important area as well. Mechanical spines, yes, absolutely. Yeah, anyone who does any kind of high impact sport like surfing or boarding, or or anything like that, spine injuries are obviously a big concern. So, devices that can either help prevent those kinds of injuries, or or help someone who's recovering for those injuries is another really great one too. Yep. Assistive devices for work, yes, that's another really interesting one too. So. There's a lot of jobs out there that require, a lot of really manual labor. And so, I think the one that a lot of people have seen is kind of that belt that people wear to kind of, prevent hernias for people who do a lot of like lifting, but also kind of more advanced devices too, like exoskeletons to kind of augment the strength and dexterity of people too. So that's another super interesting area too. Yeah, these are all awesome, guys. Yeah, it's definitely a lot of devices that I've heard of, but I haven't strictly connected with this class. So definitely, a lot of these applications, we're definitely going to cover them in the class. So so thank you guys. So anyone else want to throw any applications or examples in here before we move on? All right, and of course, we're not just limited to this session right here too. So if you think of something later that you want to learn more, you want me to cover in this class, just let me know, right? Just shoot me an email or mention it in the Discord server, and I'll try my best to kind of work it into the class, because if I can speak kind of philosophically for a moment, because I think that's what electives are all about, right? And so I know a lot of you guys are taking this as an elective. And so an elective should be something that you guys feel passionate about, right? Because the department's not forcing you to take this class. I'm not forcing you to take this class. You guys are here because you want to be, right? And so, and as an instructor, that makes me really happy, because it shows that you guys are really interested in this stuff. And so, it makes me even more motivated to make this class work for you guys and to make it as interesting as possible for you guys. So, yeah, at any time during this class, if there's something you want to learn more about, just shoot me an email. Just let me know. I'm always happy to kind of make adjustments to make this class work for you. Okay. All right, and so let's talk a bit more about complexity, because I mentioned at the beginning that what's difficult about biomechanics is not the mechanics part, but it's kind of the bio part. Okay, right. And so the primary complexity in biomechanics are these irregular application parameters. Okay, and so what I'm showing you on the right here is a knee joint, and specifically it's a finite element simulation of a knee joint. Okay, and you can see here from this geometry that it's really irregular, right? And so you're in blue right here you have your I think this is the I think it's like the meniscus or something like that, and so you can see it looks like a block, right? And so, you know, I draw shapes like this all the time in my classes, and I call it the arbitrary potato. But this literally looks like a potato, like the way that it's shaped, right? It has no rhyme or reason as to how its shape is. And you can say the same thing about the femur, and say the same thing about this about the tibia right here too, right? And same with all the ligaments that you can see attached here, right? And so none of them are a nice cylinder, none of them are a nice rectangle, right? And so, you know, none of these are going to be the nice shapes that you're that I think most of us are accustomed to working with in our classes, right? They're weird, right? And so, you know, God didn't design us, or, you know, or whatever you believe in, you know, the human body wasn't designed with SolidWorks, right? It was designed by a maniac who likes kind of all these weird shapes, right? And that makes it really hard to study, because it's hard to study these kinds of shapes, okay? And in fact, you know, I would even go out on a limb and say that, you know, biological systems probably have some of the most complex geometries and materials that engineers working with, right? And so, you know, it's hard. And so it's you know, I think I think a lot of engineers actually shy away from these biological systems, because, you know, because we don't really have control over, you know, the shape of someone's bones or the shape of someone's head, right? It just is what it is, right? And so, you know, it kind of shifts your perspective a little bit. Whereas, you know, if you're designing like an airplane, or you're designing like a thermal system, or like, you know, a building, right? You have a lot of control over, you know, what the geometry of that system is going to be, right? Because you can just fabricate it, right? You can design your beam to be whatever shape or size that you want. But for the human body, you know, the geometry is already set, and so, you know, we can't really control that. And so, you know, a lot of the work of biomechanics and biomedical engineering is kind of working around the geometry and working around the materials that you have kind of, you know, there for you, okay? And another layer of complexity is just the large amount of variability among humans, right? And so no two humans are the same size or shape, right? And so if you look at, even if you look at the hands of two humans, right, you know, they're going to be completely different from each other, right? If you look at two heads, right, say you're designing a helmet, right? If you look at your head compared to someone else's head, you know, it's going to look completely different, right? And so how you design devices that kind of work with this variability, you know, it's hard, right? And so you can't 3D print a helmet for every single person on the earth, right? And so what's the more practical case is you kind of do a more general design that can work for like a class of head shapes and a class of head sizes, right? But by making your design more general like that, you're introducing some additional risks, right? And so what you'll see later in the class is, you know, how do you balance this thing of, you know, making your device, you know, general enough so that it can work for a large population of people, but specific enough so that it can perform well, right? And so usually these two things are kind of they're kind of trade-offs for each other, right? And so you can't really have both at the same time. Okay, and so let's talk about quantitative versus qualitative, okay? Or qualitative versus quantitative, okay? And so what you'll see in this class, you know, a lot of the knowledge that we'll learn and a lot of the lectures, you know, we're going to talk mostly qualitatively, okay? And so we're going to talk about kind of the peculiarities of like a certain body part or a certain joint kind of in general, okay? And so we're not going to be doing a lot of intense calculations here, right? And so this is not a class where, you know, we're going to be solving differential equations or, you know, doing a lot of arithmetic, okay? Just because the nature of the geometry means that, you know, there's only so much that we can do with hand calculations, okay? And so, you know, what you'll see is that a lot of the class will kind of, it'll kind of almost seem like a biology class, because, you know, we're learning just kind of a lot of terms. We're learning a lot of, you know, we're going to talk about kind of behaviors in general. So, you know, we'll say the femur is approximately this thick, or, you know, it's approximately this strong and things like that, right? And so, you know, we're not going to get into a lot of numbers that you would normally see in like a fluid mechanics class or strength of materials, okay? And that's just kind of the nature of the class, just because, you know, the human anatomy is so varied and it's so strange, right? It's such a weird thing that it's really hard to kind of do really specific examples, okay? And so with that, you know, we're not going to be talking about a lot of equations in this class. And actually most of the equations that we're going to use, you know, I'm going to introduce them really early on. And so, you know, over the next couple of weeks, you know, we're going to be doing review, okay? And so if you've forgotten like your statics, your strength of materials, you know, I got you. So, you know, we're going to be doing some review of that. because I know for a lot of people, it's been kind of a while. Even for me, it's been a while to to look at kind of that fundamental stuff too. And so it was helpful for me to kind of review that and kind of write my notes again on that too. Okay, and so we'll introduce a lot of those equations like strength of materials and statics early on, and then we'll spend a lot of this class kind of applying that to different parts of the body. Okay. Because in reality, what we think of when we think of like quantitative analysis or quantitative biomechanics, where you're computing things like exact values of stress or exact values of deflection, that's really hard to do when your geometry is so complex. Okay, and so a lot of times, if you want to perform things like you want to calculate what's the stress in this muscle, or what's the exact velocity of your muscle contraction. A lot of times these situations are so complex that you have to rely on things like computations or simulations. Okay, and that's another subject that I'd love to get into, but we just don't have kind of the time in this class. But if you've taken me before, I love to do examples, and so I'll try to work in examples as much as possible. But just keep in mind that a lot of this class is going to be we're going to talk kind of in general, kind of broadly, kind of from a qualitative conceptual sense. Without any kind of numerical examples to kind of back up a lot of these things, just because it's really hard to do with kind of with a pen and paper calculations. Okay, so any questions on this so far? Imagine we were just characters out of Minecraft. That would be convenient. Yeah, it would make this class a lot easier if we were all Minecraft characters. That's for sure. Okay. All right. So let's go over the overview. Okay. And so when I was designing this class, this was kind of like the general structure of how I felt the class is going to progress. Okay. And so we're going to start on the left here, and so we're going to start with just kind of an introduction to the course, which is what we're doing now, and also some review. Okay. And so we're going to be reviewing a lot of the a lot of like the mechanical engineering that you kind of need as kind of a foundation for this class, right? And so we're going to be reviewing like strength of materials, we're going to be doing statics, forces. We're going to do a little bit of math, but not too much math too, okay? And so that's going to be the first portion of the class, okay? And then after that, I'm going to move on to a topic which I call kind of like general biomechanics of tissues, okay? And so we're going to talk, and so we're going to have 3 weeks here, and so we're going to talk about, things like bone, or have a week on bones, right? So how do bones behave? What are their material properties? How do they respond to stresses, right? We're gonna talk about muscles, right? So how do muscles behave in general? And we're gonna talk about joints too, okay? And then so we're gonna talk about those things kind of in general. And so I think that kind of sets the stage for kind of the third, portion of this class, which is kind of detailed biomechanics of the human body, okay? And so in this third phase of the class, what we're gonna do is we're gonna take kind of all the general properties that we learned in phase 2 and apply it to things like the shoulder, right? And so how does the shoulder work, right? What are the kind of the intricacies of the shoulder joint, the shoulder muscles, right? How do we design things? How do we design devices for the shoulder? Okay, and so phase 3 I think will be kind of a big phase of the class, and kind of one of the more interesting ones, I think, because I think that's when we'll start to get into much more of the applications of designing things like prosthetics or designing assisted devices for certain parts of the body, okay? And so that'll be a big chunk of the class, okay? And so at the end of the class, what I have is what I call like gross motion analysis or biomechanical modeling, right? And so, I will say that, in the last portion of the class, that's kind of like a scratch the surface kind of thing. And so we're not going to be able to get too much into it because in reality, phase 4 is kind of, what that's designed for is kind of more computational algorithms, okay? But we'll talk about things of, how do we actually model human motion? How do we actually model, someone that's actually walking, okay? And then, that has, of course, a lot of applications as well, okay? All right, question. So do we talk about fitness equipment at all as far as improving performance? Yeah, so actually that will, I don't have a specific week designed just for that, but it'll be worked into a lot of our discussions for like different parts of the body, right? And so when we talk about things like the biomechanics of the knee, right? And so we'll talk about, or biomechanics of the leg muscles in general. And so we'll talk about, what are some either fitness devices or fitness equipments that can be used to kind of enhance these kinds of things. Yeah. So a lot of the applications, I think, the way I kind of thought about it was, a lot of these applications that a lot of these really interesting biomechanics applications will be kind of worked into, our discussions, when we go over certain kinds of body parts. All right, and so if you want to kind of expand this this overview, this is kind of what I have planned, right? And so, and so this first portion, we're going to go over. Well, actually, no, the first thing we're going to do is just kind of go over just general anatomy, and then we'll do some review of mechanics. We'll do a math review, okay, and then we'll do general biomechanics, which is bones, muscles, and joints, okay, and then we'll go into detailed biomechanics of the human body, things like your upper extremity, lower extremity, and the spine, okay. And then at the end, we'll go and do, biomechanical modeling, which is, has to do more with simulations. Okay, so any questions on the course overview? Okay, right. So that's kind of just the introduction to the course in general. So, I'm actually really happy that a lot of you guys have really cool applications and really cool goals that you want to get out of this class, because I think that makes these electives a lot more fun once we get into a lot of those areas. Okay. All right, and so what I want to talk about next is the syllabus. Okay, so normally what I like to do for this is I like to print out the syllabus and give it to you guys so that you can kind of view it along with me. But of course, I'm in my apartment and you guys are wherever you are. So we'll talk about kind of the highlights of the syllabus here, but of course, you can download the syllabus that's available on the course website as well. Okay. Oh, and after this, I'll give you a tour of the course website too, because I think that's really important to go over. Okay. All right. All right. So the first thing that I want to talk about for the syllabus is the COVID procedures. Okay. And so this class is planned to be in person, and so it will be as soon as I get better. Okay. And so because this is the first time we're offering in-person classes for the first time in a while, and COVID's still going on, we need to be really strict about these safety protocols. Okay. All right. And so first thing, we want to try to social distance as much as possible. Okay. And so when you come into the classroom, luckily, we're gifted with a very nice big classroom. And so if you haven't been to E201 before, it's kind of our big kind of teaching lab. And so it's nice. And this class itself isn't too big. And so our enrollment is not too, we don't have that many people. And so we should be able to spread out pretty well. Okay. And so what I ask you guys that when you come into the classroom, try to sit at a table that either has no students at it or one student, if possible. Okay. And so if you've been to E201, you know that those desks are kind of designed so that 3 people can kind of line up, at once. But we should never be in a situation where we have 3 people out at a single desk. Okay. So try to kind of spread out as much as possible. So go to an empty desk if you can, but if not, try to go to one where there's only one person there. Okay. All right, so another thing, that we're going to require here is face coverings. And so when you're in the classroom, please make sure you're wearing a face covering that covers both your nose and your mouth. Okay. And that's, face coverings have been in the news all this time. And so, but the main reason we wear them is to kind of, catch stuff that comes out of our mouth. Right. And so, face coverings, they're not, they help you a little bit, but, they're not going to prevent particles from entering your mouth, but what they really help with is, when you cough or when you speak or when you breathe or when you kind of do all the other weird stuff you do with your mouth and your nose, right? All those particles, when they come out, they get caught in the mask instead of, being put into the air, right? And so that's kind of the main point of the face covering. Okay. All right, and so another thing is if you have to cough or sneeze, I know you have your mask on, but whenever you cough or sneeze, like a ton of particles and other gross stuff come out of your mouth. So make sure you do that into your elbow, into a tissue if possible. Okay. Another thing that the school is going to give us is going to give us a lot of cleaning supplies. Okay. And so, if you guys can help me out with this, so I'll be doing this too, but it would help me a lot if you guys kind of help out to when you come into the classroom, when you leave, try to wipe down your desk and try to, I think they're going to give us wipes. They're going to kind of give us disinfectant. So, just wipe stuff off, when you leave the classroom. I'll be doing this too. So, if you have to run, right after class, you have to catch another class, that's totally fine. I'll cover for you. But, but if you can spare just a couple moments just to wipe stuff down, I would really appreciate it. Okay. And so, for this, if you've ever been to the gym, it's always nice when someone wipes down the machine before you use it, right? And so this is kind of the same policy, right? And so when you're done, with your seat, or you're done with your chair, just kind of wipe everything down, and we'll try to keep the class as clean as possible. Okay. All right, any questions on the COVID procedures? Okay. All right, office hours. So these are my office hours for this semester. Okay, and so my office is in CS 526. Okay, and my office hours are going to be Monday morning, Tuesday afternoon, and Wednesday afternoon. Okay. And so, I always try to plan my office hours so that, I try to vary the times and the days as much as possible so that, people can, hopefully one of these will work with somebody. Okay. But, if none of these times work for you, you're, of course, you're free to make an appointment with me. Okay. And so office hours, I think the best use of office hours there for things like discussing points of confusion about the course content. If you have questions on the homework or questions on the exams, right? Those are office hours are kind of the best times to talk with them. Okay. Because office hours, when you come in, you'll have kind of my undivided attention. And so it's really easy, to talk about things that are bothering you about the class or things that you're confused about. Okay. Or if you just want to come by and introduce yourself, I'm always down to just hang out and chat too. And so that's always kind of a fun thing to do too. Okay. All right. And so this semester, since we're kind of doing, since now that we have the tool of Zoom, right? And so I'll have Zoom office hours as well. Okay. And so I'll be physically in my office. I mean, once I get better, I'll be physically in my office. But if you can't make it to my office, or if it's more convenient to you, I'll be on Zoom as well. Okay. And so if you go to the course website and you look at the homepage, there will be Zoom links there for you to join the office hours virtually as well. Okay. And so I'll be offering both. And so if you want to come on campus and talk in my office, that's great. But if you want to do it on Zoom, I'll be there as well. Okay. And so, whichever is most convenient for you guys, I'll make it work for you. Okay. Do I have gaming hours? Yes, I have gaming hours, but they're after work. But we can discuss that later. Okay, course learning objectives, right? And so just like just in the same way that we have objectives for every lecture, I think it's important to have objectives for the entire class, right? And just so that we're focused throughout the class and we kind of know what our goals are, and just so that we don't kind of stray too far. Okay. All right, and so on the level of the course, these are kind of the 5 learning objectives that I've come up with. Okay, and so the first one is to identify and describe the mechanical function of skeletal and muscular anatomy. Okay, and so we'll be covering this very early in the class. And so when we talk about the anatomy of bones and muscles, you'll have that one accomplished. Okay. All right, the second one is to describe and quantify human motion in terms of mechanical variables. Okay, and so this one is more based on how do we apply things like kinematics and dynamics of what we've learned already as a mechanical engineer, and how do we apply that to human motion. Okay. All right, and so the third one is regarding human tissue. Okay, and so explain how human tissue responds to external forces. Okay, and so that mostly corresponds to bones and muscles. Right. Okay. And the fourth one is to analyze and model human motion for engineering design. Okay, and so this is getting into a little bit of how do we design devices that can augment or affect human motion. Okay, and number 5 is just general, just to connect concepts of mechanics and materials to biological systems. Okay, and so this is kind of a learning objective that I want you guys to think about throughout the class, because like I said in the beginning, biomechanics is not really anything special, right? It's there's a lot of overlap with mechanics, as you know. Okay, but I think a lot of times people don't really associate the two, because they think of them as like kind of two completely different schools of thought. Right? But it doesn't have to be like that, because there is a lot of overlap, and there is a lot of ways that you can connect what you already understand as an engineer to biological systems. Okay, and what I hope at the conclusion of this class is that you can do that. Okay. Even if it's not things that we specifically went over in the class, but if you can connect things that you've learned in previous classes to biological systems, I'm going to call that as a win for this class. All right, let's talk deliverables. Okay, and so there's going to be 6 homework assignments that are planned, 2 midterm exams, and 1 final project. Okay. And so just like I have for all my classes, the lowest homework assignment will be dropped. Okay, because I know that things happen during the semester. I know a lot of you guys are working at the same time, or a lot of you guys are working, multiple different class or tons of different classes too. And so, I know that it's difficult sometimes to be on top of homeworks for all your classes at the same time. Okay, and so I want to be flexible, and giving you guys the flexibility of dropping one homework assignment. Okay, but with that said, please do them all. And so, the way I design my homework assignments, yes, I know my homework assignments can be kind of lengthy and they can take some time, but I always design them with a purpose, right? Because in what I've found is that learning is kind of like a two-step process. I think part of it is you go to the classroom and you kind of you interact with your classmates and you learn from the material and the lecture, right? That's one thing that's needed from learning. But the other thing that you really need to do is you need to actively kind of engage with the material. Okay, and so the homework assignments are kind of my way of giving you an opportunity to actively engage with the material, right? To kind of test your understanding, to kind of test your knowledge, to see if you can actually solve a problem with the knowledge that you have, right? And a lot of times to identify some shortcomings in your knowledge too, right? I know a lot of times there's so many times, even now that I'm in this position as an instructor, right? There's so many times where like I prepare a set of lecture notes, right? And I think I understand it, and then I go to design the homework assignment, and I go to try to do a problem, like, okay, maybe I don't really understand this as well as I think I did, right? And a lot of times it takes the homework assignments, or it takes being challenged, it takes actively engaging with the material to really identify those kinds of shortcomings in your knowledge, right? And so that's kind of what I designed the homeworks for. So even though I know the lowest homework is dropped, but please do try to do them all, because it's I think it's a really important part of your learning, right? All right. Oh, 1 year. MATLAB is hard. Yeah, MATLAB, I think MATLAB is one of those things where it's kind of a very different trained mindset that you have to approach it with compared to other stuff. So yeah, a lot of people really struggle with that. Yeah, we're not going to be doing any MATLAB in this class. I contemplated it for a while, but I think there's enough for us to cover where we don't have to get into MATLAB. And so yeah, we're not going to do that in this class. But yeah, it's hard, and programming and MATLAB in general is something that you have to constantly practice in order to really get good at. Okay, so the midterm exams, they're not going to be cumulative, and so each midterm exam will cover, I think, maybe about a 5 or 6 week chunk of the semester. Okay, and so I think that makes things a bit easier. Okay, and so let's talk about the final project, right? And so the final project in this class, as you guys have seen, as we've talked about in this class, there's a lot of really interesting topics in biomechanics, a lot of really interesting applications out there, and way too much well, there's way too much out there that that I can actually cover in detail in just one course like this, right? And so the final project is I want to use the final project as an opportunity for you to really dive deep into a biomechanics topic that you are really passionate about, right? Whether it's exercise equipment, or whether it's exoskeletons or prosthetics, right? We'll be covering these things in the class, but we're going to go over them a little bit briefly, just because of the sheer volume of stuff that we have to go over. And so the final project is kind of your chance to kind of dive into the primary literature of how these devices work, and to write a report on it. Okay, and make a presentation. Okay, and so because I do want to have this presentation aspect, that kind of necessitates us to kind of do this in groups. And so the final project will be done in groups of about 3 or 4 students. Okay, and so we'll talk about this a lot more later on this semester, but that's kind of what you can expect. Okay. All right, so let's look at some dates. And so here are the dates for the exams. Okay, and so they're both going to be on Wednesday. So the first one's going to be Wednesday, September 29th, and the second one's going to be Wednesday, November 10th. Okay. And so even though I know I said here that there's no makeups planned for the exams, I know that this is a very unique semester because it's, COVID is still obviously a big thing. And so, if you can't make one of these exam dates, if you have an emergency, you test positive for COVID, please, let me know, and I'm more than happy to accommodate you. Okay. Of course, as with anything, the sooner you let me know, the easier it is to accommodate these things. But, I'm definitely, we're going to be flexible with these things, because it's, I think there's a lot of things that can happen this semester. And so, I don't want an emergency to come between you and doing well in this class and enjoying this class. Okay, so please, please don't hesitate to reach out to me, because I want to work with you guys as much as possible on these things. Okay. All right, and so the final reports, your final projects, that's going to be due on Monday, December 20th. And so that's going to be the Monday after finals week. Okay. And so, with final projects, I like to give you guys as much time, as much flexibility as possible. So I always make them due after finals week, but I can't have them be due too late, because I need to still have time to grade them all. And so that Monday, December 20th is kind of the last day that I can have it due and still have time to grade your projects and all the other projects that I have for my other courses too. Okay. Okay, so any questions on this so far? Okay. All right, so course grade breakdown. So pretty standard stuff here. Okay, and so the way your grade's going to break down is it's going to be 20% homework, 20% for each of the midterms, and your final project's going to be 40%. Okay, and then once all the grades are in, I'm going to assign letter grades according to this scale right here. So this is pretty standard. Okay, but I'm flexible with these ranges too. Okay. And so, if you're on the edge, of course, I take things into account, of whether you turned in all your homeworks, or, whether you showed up to all the lectures, things like that. So, these are kind of the base. Think of these as kind of like the baseline ranges, but, there's always some flexibility here. Okay. All right, textbooks. So, as always with all my classes, the textbook's not required because they're expensive as fuck, right? I hate buying textbooks too, and I know, they've only gotten more expensive over time, but these will be a useful reference. Okay, and so especially this first textbook, we're going to be referring to that one a lot in this class, and so that's going to be a useful one to pick up if you do want to reference. But all the content in this class, all the homeworks you can do with just the lecture notes that I'm going to post. Okay, and so you don't need to buy these textbooks because I post all my lecture notes. But if you do want a reference, just to see prettier pictures, or just to see some more detailed information, here are the two references I'm going to use for this class. Okay, especially the first one. Okay. But again, I'm not going to assign any reading from the textbook. I'm not going to assign any problems from the textbook. So there's no practical need to have it. But if you want it, you can. These are the ones that you can get. Okay, and if you can find a cheap version, or if you can find even a version for free from the high seas, then I would definitely go for that. Okay. All right, course website. So we're going to be using Canvas, and so I think this is the third semester now I've used Canvas, and so hopefully everyone's used to it by now. Okay. But the course website is going to be used to post all the lecture notes, all the lecture slides, homework assignments, homework solutions, exam solutions, study guides, basically any material that I produce for this class, it's going to be posted on Canvas. And so make sure you're checking back on the website regularly for updates. Okay. And so any announcements that I also make on Canvas will also be emailed throughout the class. Okay. And so, and thankfully that worked, because, I sent that announcement about this class being virtual, and, and 25 of you guys are here. So that's good. Okay. And so I've also made a Discord server. And so this is something that I started, from the virtual instruction, just because, with virtual instruction, we don't have a physical classroom to call home. And so, it's a little bit different this time, because we do have, we are meeting in person. But I think the Discord server, was a net positive, because I think a lot of really good interactions occurred on that Discord server. Okay. And so, if you want to join the Discord server, the link for that is on the Canvas site. So you can go ahead and click that. Okay. Once you pop into the Discord server, you can see that I've made several different channels. And so you can pop into the introduction channel to introduce yourself. Okay. Just so that everyone kind of knows who you are. Okay. But I've also made channels for asking questions. I've made channels for memes if you want to share them. Right. I had one class last semester where they were very active in making memes of me almost every single class, and I loved it. I thought it was really great. Okay. And so, definitely use the Discord server. I think in a lot of ways it's easier to kind of ask something there and get an answer there, faster than if you would ask me. Okay. And so if you have questions on the homework that you want to ask just in general, definitely use the Discord server, and and help each other out through there. Okay. Because I try to be as active as I can with emails and with messages, and I try to respond as fast as possible. But but I'm just not on all the time. And so, a lot of times it's faster, to ask someone else for help through the Discord server, and someone will come to your aid. Okay. All right. And so before I move on, I want to have one important note. Okay. And so, I know with Discord, you can message me directly on there. Okay. And you can do that, but please try to save this for just emergencies. Okay. And so last semester, I wouldn't say people abused it, but I definitely had a lot of spam that came through my Discord DMs that was really difficult to deal with, right? And so one thing in particular is that at the end of last semester, it was my fiance's birthday, and I had promised to take her out for the entire day, and it was and unfortunately, she can't choose when she was born, and she was born, the weekend right before finals week, right? And so I kind of messaged the class. I said, hey, I'm going to be out all day today. If you have questions on the projects, try to save that maybe for Sunday, and we'll get to that. But I got 15 different people contacting me on that day, and it was a little bit tough because it's normally I a lot of times I'm on my phone, or a lot of times I'm answering emails from you guys throughout the day. But I wanted that day just to kind of just be about her, and I was getting notifications left and right. So and so you can message me on Discord, but try to save it for emergencies. So if you have a question that that only I can answer, that then you can send me an email, and I'll answer my email there. But if you have a question on the homework or a question on the project, try to use the channels on the Discord so that other people can view your questions, and then so that other people can answer, and then so that other people can benefit from it as well. Okay. And so only message me directly on Discord only if it's if it's an absolute emergency. Yeah. Okay. All right. Course policies. And so late homeworks, I do accept late homeworks. Just because I know it's a lot of times it's hard to kind of stay on top of all the deadlines with all just the stuff you guys have going on. And so I will accept late homeworks, but for each day that the homework is late, I'll dock 10% from its points. Okay. And if the submission on, so a lot of our homeworks you can either hand to me in person in the lectures, or you can submit it on Canvas. But if the Canvas thing is closed, then you can scan your email or you can scan your homework and email me directly as well. Okay. Regrades. And so I do regrades, okay, because I make mistakes just as much as anyone. Okay. And so if you think, and so if I made a mistake in grading your homework or the exams, please let me know. But I do place a time limit on this. And so, I do place a time limit of 1 week after I return whatever that graded material is to you. Okay. And that's mostly to encourage you guys to look at the graded assignment, as soon as possible. Okay. Because, I think what happens a lot of times, and I was guilty of this too, that, I receive maybe a homework back or an exam back, but then I don't really look at it until I need the points, right? And so a lot of times, maybe I won't look at my exam until the end of the semester when I'm at like an 89.2 and I need that extra few points to bump me up to an A. And I'm like, well, can I get some extra points on the midterm that happened weeks ago? And so, I get it, I've been there too, but, but when I grade your guys' stuff, I try to leave as many comments and a lot of feedback as much as possible. And I want you guys to be looking at that, kind of when I give it back to you, right? Because the point of the feedback and the point of the comments is to kind of help you guys learn the material better, right? And it doesn't really help if you're looking at comments of something that we learned 10 weeks ago. If you're looking at that now, it doesn't really help, right? And so you kind of need to read that feedback when we're kind of on that same topic in the class, right? And so the reason I have this kind of deadline is to kind of encourage you guys to be looking at that feedback when I give it to you in a timely manner, okay? So that the feedback is actually useful to you. All right, so emails. And so, I'm teaching 4 different classes this semester. And so it would really help me if you guys could put EGME 441 in the subject line, right? So that way I know immediately, what class you're asking me about, right? Especially because I know some of you guys also are in multiple of my classes. And so, if you're emailing me about this class, try to put EGME 441 in the square brackets so that kind of I know exactly what you're asking about, okay? And I try to be as prompt as I can with email responses. And so, 48 hours at the maximum. So I try to email back within 24 hours, but 48 hours is kind of the maximum, except on weekends. So weekends, I might be out or I might be doing stuff. And so, I might not respond right away on weekends. But I try, but most of the time I try to leave Sunday morning for answering emails as well. Okay. All right, graduate credit. And so, if you're a graduate student or you're planning to have this class count for graduate credit, you must complete an additional assignment. And so that's department policy. And so that's not something that's up to me. Okay. And so the extra assignment in this class will be a literature review, right? And so I'm going to have you look for a research paper, primary literature, for a topic that in biomechanics that you find really interesting. Okay, it could be a paper that you use for your final project as well. Okay, and I want you to write kind of an individual review, an individual summary of that paper. Okay. And so if you are planning to take this course for graduate credit, please let me know as soon as possible, because there's a form that I need to sign too. And so we want to make sure that we sign that form before the deadline passes. Okay. All right, academic dishonesty. And so I have to say this kind of every semester. It's my least favorite part of the semester, but I have to say it. But academic dishonesty will not be tolerated in this course. Okay. And so if you commit academic dishonesty, at the very least, it's going to result in a 0 on that particular assignment, whether it be a homework or an exam. Okay. But if it occurs on something like an exam or the project, it's going to result in an F for the course and a referral to student conduct. Okay. And so it's a hard line policy, and I get that, but it's something that it's something that's kind of necessary. Okay. And so the reason I have this hard line policy is that cheating at the end of the day, it takes away from your learning, right? I don't think I need to tell you guys that, right? And so my goal for this class is not to be a gatekeeper, right? It's not to kind of see who passes and see who fails, right? I'm not here to kind of judge how good you are, right? My job here is to make sure that you guys leave this classroom with more knowledge than you came in, right? And so if you're cheating, then you're not really learning anything. Okay. And so if you ever find yourself struggling in the class, if you don't really understand anything, you're struggling to keep up with deadlines, or you don't really know what's going on, right? Please, reach out to me. Okay. I'm not here to judge you. I'm not here to criticize you. I'm not here to make you feel bad about anything, right? I'm here to help you, right? I'm here to support you, and I take that really seriously, right? And so if you come to me and you honestly tell me that I'm really struggling with this, I really have no idea what's going on, right? What I'm going to ask you is what can we do to get you to a point where you're learning, okay? And so I would much rather have that than to find out later that you cheated on the exam, okay? Because once you've cheated, there's nothing I can do, right? There's the only thing I can do is I can file the report and fail you from the class. But if you tell me early on that I'm really struggling and I really need some help, then I can work with you and I can get you to the point where you feel like that this class is being good for you, okay? And so please reach out to me. I'm not going to judge you. I'm not going to criticize you or anything like that. I'm really here to help, and I'm really serious about that. Okay. Okay. Question?
So they're saying like academic dishonesty isn't going to be tolerated in the course, like when it comes to homework and exams and stuff.
Yeah.
But like, if we're asking other students on the Discord for help with the homework because you're not available, or if we're like collaborating with another classmate to do the homework together, and let's say we get the same answer or that's slightly wrong, and like one of the steps is wrong and it looks exactly the same, are we not allowed to do our homework together, or how is that going to work when it comes to judging academic dishonesty?
Yeah, no, that's a great question. So absolutely, I want you guys to work together on the homeworks, and so use that Discord server, help each other out, right? I think what a lot of people don't realize, and I didn't realize this until I was an instructor too, that it's really, really obvious when someone's just kind of copied the answer from somewhere else, right? I honestly I don't think it's going to be that big an issue in this class because it's an elective and it's the first time we've taught this. But if it's something like heat transfer, right, or something like fluid mechanics, right, like a lot of times I'll get answers from in the homeworks or the exams where they use methods or they use formulas. Or they use logic that we didn't even go over in the class at all, right? And so those are cases where they obviously got someone else to do the problem for them, and they just copied the answer, right? And it's very, very obvious when that happens. And so if you're just working together with someone in the class on the homework, that's fine. And in fact, that's awesome. I think that's great. But if you're getting help from somewhere else, or you're just copying straight from someone, even if you're just copying straight from someone in this class, it's often really, really obvious when that happens, right? But if you guys are honestly working together and you're both kind of struggling through the homework together, I can see that, and it's not that hard to tell, from one case for another. So absolutely, help each other out, work together on the Discord, but just don't straight copy from someone, because it's kind of pretty obvious when that happens. Yeah.
Okay, so like with the first case you described sounds kind of like someone just posted it on Chegg or something. Are we still allowed to do that? Like if we are having trouble with something and like not copy it straight up, but just, use that resource, as long as it's not obvious that, we didn't attempt it on our own and we just were like, it's due tomorrow, I'm just gonna copy it.
Mhm.
Like, is it okay if we use it as a resource to, help us better understand the concept, or should we not?
I would prefer that you come to me first,
Okay.
before you use something like that. But if it's for a homework assignment, I don't mind. I don't mind if you use it in kind of the way that you described. So you just use it as a resource, not the only resource, right? And so if you use Chegg, and you get, maybe a response from there, but you also, you talk to your classmates about it, you talk to me about it, and you kind of, form your answer based on kind of a triangulation between the three. That's okay to me. But I would have a strong preference. Let's talk to me first and see if I can kind of help you get through it as much as possible. But if you need some extra help, or if I'm not available and you post on Chegg, but then you don't copy it exactly, then that's okay to me too. But try to use the material that we use in the class, and try to use me as a resource, and your classmates as a resource as much as possible before you use external stuff. Yeah.
Okay, yeah, I think office hours are preferable to something like Chegg anyway.
Yeah.
So, but I was just curious about that.
Yeah, no, these are great questions too, and I think a lot of times it's a little bit difficult to kind of discuss these things. So I'm glad we had that discussion to kind of define what's good and what's bad. So yeah, thanks. So thank you for asking those questions. All right, and so there's also questions about the graduate credit form, and so I think if you're an actual grad student, I don't think there's a form, but definitely check with the counseling office, because it's kind of been a while since I've done it. But once you get the form, then you can send it to me, or you can wait till we're back on campus and I can sign it physically as well. Yeah. So either one is fine. Yeah. I think if you want to if you want the form, I think if you ask the graduate student, if you ask your academic advisor, they'll know what form it is, right? Or if you ask the department, they'll let you know as well. Okay. Okay, and so we're almost done for today, and so we have 4 more minutes. And so the last thing I want to let you guys know about is the first homework. And it's not really a homework; it's just kind of a task that you need to do. Okay. And so for your first homework, I want you guys just to send me an email, right? Just to introduce yourself, right? And so I do this with every class. And so, even if you've had me for multiple classes before, right? You're not the same person as you were, before the summer. And so, just update me on your life, right? And so I like to do this just because it's, I think it helps give me a sense of, who's in the class and what you guys are trying to get out of it. Especially for an elective class like here. Okay. And so I go through and I read every single one of these, and I answer every single one. So, definitely don't feel like your email is going to the abyss, because I do read them all. Okay. And so if you want some questions to answer, you don't have to answer these 4 questions, but these are kind of just things to help get you started, right? And so things like, what kind of career are you hoping to have? What do you want to get out of this class? Do you have any worries or concerns? Or just what are your interests and hobbies? Okay, so you don't have to answer these, but they just kind of help get the conversation started, right? And so you can even just send me an email, just say that here's my email, give me credit, and I'll give you credit for that. But of course, the more that you write, the nicer it is, and it's I learn more about you too. So share as much as you feel comfortable with, but the more you share, I think it's nicer too. Okay. If you have me for 2 classes, you can just send 1 email. Yeah, that's fine. Okay. And so the due date for this is going to be this Friday. And so if you can send me an email before Friday, August 27th, then that would be great. Okay. All right. So any questions on this first lecture here? Okay. Right, and so there's no questions. I think we'll call it here today. And so I did want to go through the course website a little bit, but I think we'll save that for next time because we just have 2 minutes. Okay. And so I want to thank you guys again. I know it was kind of a last minute thing to go virtual, but hopefully we'll be back in the classroom soon. And so have a great evening, everyone. Hope you enjoy your first week, either if you're back in school or maybe not, your first week of this semester. And I'll see you guys on Wednesday.
Thanks, Professor. Hope you feel better.
Thanks, guys. Thank you.
Thank you, Professor.
Thanks,
Oh,
guys.
and I'm sorry,
Thank you,
one last
Professor.
thing.
Yep,
Are you
what's
going to update us with an email about your results?
Yes,
And then we can go
yes.
from there?
Yeah,
Okay.
so at the very least, I'll send you an email tomorrow about what we're gonna do on Wednesday. And so if I don't get the test results back, then we'll still be virtual. But if I test negative, then I'll let you guys know. Yeah.
Okay.
Thank you.
Thanks, guys. Yep. See you next class.